how did Earth's continents assemble and break apart? But this process is driven by deep, powerful internal heat engines. These mantle plumes act like colossal conveyor belts for the plates. The surface is fractured into these rigid tectonic plates. Plates interact constantly at their edges, creating geological drama. Subduction zones occur where one plate dives beneath another. Divergent boundaries pull the lithosphere apart, forming new crust. Over millions of years, these movements create massive landmasses. Now that we understand plate movement, let's explore supercontinents. These were colossal landforms, aggregating nearly all continental crust. On the formation event, the final collision, defines a true supercontinent. These collisions created immense mountain belts where plates met. The interior climate became extremely arid and hostile to life. Biodiversity suffered due to the limited coastal habitats available. The ocean currents were drastically altered, impacting global weather systems. But internal forces always begin the cycle of disassembly again. Heat builds up beneath the massive continental root structure. This thermal uplift initiates the process of continental rifting. Fault lines appear, carving deep scars across the ancient rock. Eventually, the ocean breaches the lowest points of the Rift Valley. This marks the official birth of a new ocean, driven by seafloor spreading. The original landmass is now irrevocably separated into two major entities. But each fragment carries the unique geological signature of the former Union. Coastal environments flourish where the new shorelines are established. Our seafloor spreading provides undeniable evidence of this movement. At the mid-ocean ridge remains the active engine for this separation. Beyond simple drift, continents also experience significant rotation. This rotation creates varied coastlines and new tectonic stresses. Meanwhile, smaller continental fragments collide and accrete onto the main bodies. These ancient, stable cores resist destruction throughout the entire cycle. But the pieces are now separated, but the cycle always trends toward reassembly. And the oceans created by breakup must eventually close through subduction. And this process drags the continents closer over geological timescales. The vast ocean shrinks as the next collision becomes certain. A volcanic activity flares up along the converging margins before impact. The final stages involve the collision of two continental crusts. Continental crust is too buoyant to fully subduct, causing intense compression. This immense squeezing thickens the crust, building towering mountain ranges. But the process culminates in the formation of a new, singular continental block. But this continuous cycle has repeated many times throughout Earth's deep history. The earliest recognizable assembly is known as Columbia, or Nuna. It existed billions of years ago before succumbing to rifting forces. While later, Rodinia formed, marking another major planetary reorganization event. Understanding the heat flow is key to predicting these massive continental shifts. Rodinia's breakup was particularly energetic, creating vast new shallow seas. This dispersal allowed life to diversify rapidly in the new oceans. Centuries later, the trajectory was set for the most famous union. The Pangaea represented the apex of continental unity in recent geological time. Its vast interior created deserts, while the Tethys Sea remained central. Even at its peak, the forces of erosion were constantly at work. And the immense thermal load inevitably caused another massive upwelling. This thermal bulge initiated the final, dramatic rifting that defines our world today. First, the central rift opened, creating the Atlantic Ocean basin. The Laurasia and Gondwana separated, beginning the familiar continental arrangement. That new spreading center remains highly active even now. North and South America are still pulling away from Africa and Europe. Conversely, the massive Pacific plate is shrinking due to intense subduction. But the ongoing India-Eurasia collision is the direct legacy of Pangaea's end. Scientists predict the next supercontinent, sometimes called Amasia, will form. The Earth's surface is never static, it is an ever-reworking engine of creation.